Lesson 9.1, Graphing Sine and Cosine Functions. Our essential question: how do you explore characteristics, stretch and shrink, translate and reflect graphs of sine and cosine functions? Standard 9.4 Introduction, Exploring Characteristics of Cosine Functions. So we have the table for y equals cosine of x, and x is supposed to be the angle in radians. So here are our x values all in pi, and I would like you to find the y values. You're going to use your calculator to type this in. When you do that, you will observe that negative 2 pi is 1, and that also positive 2 pi is 1, 0 is 1, negative pi is a negative 1, and pi is a negative 1. All of the whole pi values are either 1 or negative 1. You'll observe all of the half values are 0. So negative 3 pi halves is 0. Negative pi halves is 0. Positive pi halves is 0. 3 pi halves is 0. All of the halves are 0. All of the remaining values, which are fourths, are going to be the square root of 2 over 2. Just, are they positive or negative? Negative 7 pi over 4 is the positive square root of 2 over 2. Negative 5 pi over 4 is a negative square root of 2 over 2. So positive, negative. This one is going to be negative, and then positive. Positive, then negative, negative, positive, positive. So positive, negative, negative, positive, positive, negative, negative, positive, positive. Looks like they come in pairs of 2. Now, so that I can be able to graph these, I need to know what the square root of 2 over 2 is. And that is 0.707107, which means negative square root of 2 over 2 is negative 0.707107. And now my next job is to graph these. So I'm being asked to plot the values of the table that we just figured out for cosine, for y equals cosine of x. So my first was negative 2, positive 1. Negative 7 pi fourths was square root of 2 over 2. Negative 3 pi halves is 0. Negative 5 pi fourths is negative square root of 2 over 2. Negative pi is a negative 1. Negative 3/4 pi is negative square root of 2 over 2. Negative pi halves is 0. Negative pi fourths is square root of 2 over 2. 0, 1, pi fourths, square root of 2 over 2. Pi halves, 0. 3 pi fourths, negative square root of 2 over 2. Pi, negative 1. 5 pi fourths, negative square root of 2 over 2. 3 pi halves, 0. 7 pi fourths, square root of 2 over 2, 2 pi 1, 9 pi fourths, square root of 2 over 2, and that is it. So I see that cosine looks like this. So what do I observe of this problem? I observe that it always is stuck between right here, this positive 1, and this negative 1. I observe that I have x-intercepts here, 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 and here. I observe that I have a maximum value here, here, and here. I observe I have a minimum value here and here. And I observe that I have some increases and decreases. My increasing started right here at negative pi, and I continued up until I stopped right here at 0. My next increasing started right here at pi, and I increased until I stopped right here at 2 pi. These are my intervals of increasing. How do we write intervals of increasing? I say that I observed I started right here at negative pi, and that it continued on until I stopped at the 0. This was my other interval of increasing right here. How do we write it? I started at the pi, and I continued on until I ended at the 2 pi. Well, what about decreasing? I see that my decreasing started right here at negative 2 pi, and I went down until I ended right here at negative pi. So this right here is my first area of decrease. I have another area of decrease. I started right here at the 0, and I went down until I ended right here at the pi. So this is my second area of decrease. I don't have any other areas of decrease because they want us to look between negative 2 pi and pi. So this is where I'm looking. I only have 2 areas of decrease. So how do I state this area of decrease? I started at a negative 2 pi, and I continued on until I ended at negative pi. How do I state this area of decrease? I see that I started at the 0, and I continued until I ended at the pi. So this was a max, this was a max, and this was my max. I observed this x-intercept, this x-intercept, this x-intercept, and this x-intercept. This was a min, and this was a min. This was a decreasing interval and another decreasing interval. This was an increasing interval and another increasing interval. All along the way, I saw that I was stuck between a positive 1 and a negative 1. Highest it ever went was positive 1, lowest it ever went with negative 1, and it just stuck between those two. So now that we've identified all of the key points on the graph, we're being asked to organize them in a list. So the first thing we need to find are our x-intercepts. So my x-intercept is where I cross the x-axis. I notice I have an x-intercept at negative 3 pi halves, an x-intercept at negative pi halves, an x-intercept at pi halves, and another x-intercept at 3 pi halves. So let's go ahead and write that on our list. Next, we're looking for the x values of our local max. We have 3 maxes. So the first max was negative 2 pi, our second max was at 0, and our third max was at 2 pi. Next, we're being asked to find the x values of the local mins. We have 2 mins. The first minimum's x value is negative pi. The second min's x value is pi. Areas of increasing and areas of decreasing. Increasing is when you're going up the roller coaster, up the mountain. So I went up the mountain here, and we identified this area of increase. And I went up the mountain here, and we identified this area of increase. Decreasing is when you go down the roller coaster, down the mountain. We went down here, and we identified it as this interval. And we went down here, identified it as this interval. We are not including this part because the problem told us to only focus between negative 2 pi and 2 pi. This part of the problem occurs after the 2 pi. So we're not focusing after that problem. We're going from 2 pi to negative 2 pi. The last question asks us, is cosine even, odd, or neither? You'll remember even means that they look the same if you fold them right along the x-axis. Odd says it looks the same if you turned it upside down, a rotation of 180 degrees. Neither means it doesn't do either of those things. So looking at our cosine, I notice that if I split it right down the middle right here, that the left side does exactly look like the right side. So that means it must be even. So what are some characteristics that we observed of the cosine function? I observed that all of my maxes are at the same value, and that same value just all happens to be 1. I observed that my minimums are all at the same exact value, just happens to be that same exact value is negative 1. I observe that if it started here, it finished its U, and it actually repeated that every single time. So I have like a curvy U repeating every single time. So I observe that this visual is the same as this visual. It is repeating. I also observed that my x-intercepts all occurred at the pi half marks. The last question. Describe the end behavior of cosine. I see that as I travel to the right, so as my x values are going to be getting bigger and bigger, it just goes 1, negative 1, 1, negative 1, 1, negative 1. It looks like it's going to keep oscillating between 1 and negative 1. It is never going to end. The minute it hit 1 again, it turned right back around. It's going to go down to negative 1 again. So I see that it is neither increasing or decreasing. It's not going to any single one value. It is oscillating between negative 1 and 1.